Hey everyone, and welcome back. If you're a UPSC aspirant prepping for those mains and prelims, this deep dive is for you today. We're going to be tackling, a current affairs issue that could be a total game changer across multiple exam papers. We're talking about the growing crowd in space, but here's the twist. What if the climate crisis is making space even more crowded?
It is a surprising connection, isn't it? We tend to think of climate change as just an earthbound issue, but its effects are literally reaching for the stars.
Exactly. And today, we're diving into this super fascinating article from physics.org, which is like a leading platform for, all things science. And they've highlighted some really eye-opening research from MIT that connects greenhouse gases to the sustainability of, satellite operations. All those satellites we're launching for communication, navigation, and of course, internet constellations like Starlink.
And that's really where the concern is. We're in this era of just unprecedented satellite launches, like just adding thousands of objects to low Earth orbit, which is where, most of our space activity takes place. And this boom is creating this growing problem, space debris. And as this new research suggests, climate change might be making that problem even worse.
So let's break this down for our listeners, prepping for those UPSC exams. The MIT study found that as we, pump greenhouse gases into the atmosphere, they're actually causing the thermosphere to shrink. Now, that's the layer of the atmosphere where most satellites orbit.
No, you might be wondering, how can gases warming the Earth cause cooling and contraction higher up? It all comes down to how greenhouse gases interact with, different layers of the atmosphere. Down here, they trap heat, leading to global warming. But up in the thermosphere, they actually radiate that heat away, causing it to cool and contract.
Okay, so the thermosphere is shrinking. So what does that mean for all the stuff we put up there, like the satellites and the, ever-increasing amount of space junk?
Well, this is where the concept of atmospheric drag comes in. So imagine a satellite orbiting Earth. It's constantly encountering these tiny particles in the atmosphere, and it creates friction and slows it down. And this drag is actually beneficial because it helps deorbit old satellites and debris, pulling them down to lower altitudes where they burn up in the atmosphere.
So it's like a natural cleaning mechanism for space.
Right,
Like,
exactly. But here's the problem. As the thermosphere shrinks due to greenhouse gases, it becomes less dense, which means less drag. And less drag means that defunct satellites and debris stay in orbit for much longer, increasing the chance of collisions.
it's like we're messing with the, delicate balance of space. And the researchers, they actually went a step further and calculated something called the carrying capacity of low Earth orbit. Sounds kind of familiar from ecology.
Right, absolutely. Just like ecologists study how many individuals an ecosystem can support before it becomes unsustainable, these researchers applied that concept to space. They used simulations to model orbital dynamics and collision risks under different greenhouse gas emission scenarios. They looked at different altitude ranges and asked, what's the maximum number of satellites each region can handle before it becomes unstable due to collisions?
And what they found is pretty alarming, especially for, us here on Earth. They predict that by 2100, the carrying capacity of key orbital regions could be slashed by like 50 to 66% compared to, a scenario where emissions stay stable. That's a huge reduction.
It is, and it has major implications for everything from satellite services like GPS and communication to, even future space exploration missions. Imagine a scenario where we can't launch new satellites because the risk of collisions is just too high. It could even impact international collaboration, on space projects as competition for that limited orbital space just intensifies.
So we're facing like a potential space traffic jam. And it's all linked to, our actions here on Earth. It's like that saying, what goes around comes around. But in this case, it's going up and staying up there.
Exactly, and what's even more concerning is that some orbital regions are already nearing capacity today, even without factoring in those long-term effects of climate change. This research really highlights the urgency of the situation. We need to act now to prevent, a potential disaster in space.
And the researchers even mentioned the possibility of a runaway instability in orbit. Can you explain what they mean by that? It sounds a bit like a science fiction movie plot.
It does sound a bit dramatic, but the reality is it's a very real possibility. Imagine a scenario where a single collision creates this cascade of debris, each piece of debris colliding with others, generating even more fragments. Eventually, you end up with a debris field so dense that it becomes incredibly dangerous, if not impossible, to operate in that region of space.
Wow, that's a sobering thought. It really highlights the interconnectedness of seemingly, separate issues like climate change and space sustainability.
It does. And for you, UPSC aspirants out there, this topic has significant relevance across multiple exam papers. In the Science and Technology paper, you could be asked about the mechanisms behind thermosphere contraction and its impact on orbital mechanics.
And of course, the environment paper is a natural fit, where you need to demonstrate an understanding of the link between climate change and space sustainability.
Then there's the International Relations paper, where you could discuss the potential for both conflict and cooperation as space becomes more crowded and contested. How will nations collaborate on space projects? How will they manage the increasing risk of collisions and debris? These are critical questions that, future diplomats and policymakers will need to address.
And finally, for the current affairs paper, it's all about staying updated on the latest developments in space technology and policy, particularly within India's burgeoning space program. Understanding the challenges and opportunities presented by this research will be essential for anyone aiming to contribute to India's future in space.
Yeah, it really drives home the point that even as we strive for a more sustainable future on Earth, at shifting to cleaner energy, reducing our carbon footprint, we need to be mindful of, those potential consequences for space.
Precisely, this research presents a complex dilemma. On one hand, we need to combat climate change to protect, our planet. And on the other hand, those efforts could inadvertently impact the sustainability of our activities in space. It's a reminder that we need to consider the interconnectedness of everything.
So what can we do about it? Is there any way to reverse this thermosphere shrinkage? Or are we just destined for, a future of space junk collisions and limited orbital access? Well, that's the million-dollar question, isn't it? While reversing thermosphere shrinkage might be a long shot, we're not completely powerless. The most obvious solution is to reduce greenhouse gas emissions, which would, in theory, mitigate those long-term effects.
Right. But that's a global challenge that requires, international cooperation and significant changes to our energy systems and consumption patterns. It's not something that will happen overnight.
Absolutely. But there are also technological solutions that we can explore. For example, we could develop more efficient deorbiting strategies for satellites and debris, perhaps using technologies like solar sails or tethers to, increase drag and accelerate their descent.
And imagine there's a lot of ongoing research into space debris removal technologies, like things like robotic arms or lasers that could capture or nudge debris out of orbit.
Exactly. These technologies are still in their early stages, but they hold promise for mitigating the risks posed by space debris. The key takeaway here is that this research highlights the need for a multi-pronged approach, reducing emissions, developing innovative technologies, and fostering international collaboration on space sustainability.
And for our UPSC aspirants listening in, remember, this isn't just about understanding the science. It's about understanding the policy implications, the ethical considerations, and the potential solutions. This is a dynamic and evolving field, and staying informed is crucial.
Absolutely. And that's why resources like physics.org, where we found this fascinating article, are so valuable. They keep you updated on the latest scientific discoveries and help you connect the dots between these seemingly disparate issues.
So what does this all mean for you, our listener? It means recognizing that we're at a critical juncture in our relationship with space. Our actions on Earth have consequences that extend far beyond our planet. We need to embrace a mindset of responsible innovation and global cooperation as we continue to explore and utilize space.
And for those preparing for the UPSC exams, this research is a goldmine of potential questions. Think about how this issue could be framed in the science and technology environment, international relations, or even the ethics paper.
We've covered a lot of ground today, but this is really just the tip of the iceberg. We encourage you to delve deeper into this topic. Read the full article on physics.org and let us know your thoughts in the comments. We'd love to hear your perspectives and answer any questions you might have.
Don't forget to like and subscribe to our channel for more deep dives into crucial current affairs topics that could give you an edge in your UPSC preparation.
Until next time, keep exploring, keep learning, and keep aiming for the stars.